So hello, welcome to our webinar ZEISS CALYPSO 2022, new functions in our new version. I'm sitting here in Oberkochen in the Academy together with Herbert Books. My name is Günter Haas and I'm from the software product management CALYPSO, and during this webinar we will have a look on all our new highlights in CALYPSO 2022. We will start with all our CAD and PMI improvements in CALYPSO 2022. So first, I will start with points from PMI. We will now create as a space point. In the past, if we got a point from PMI characteristic or feature, we have been created as a touch point, and now we are using the space point. Space point, the advantage is that the vector is perpendicular to the surface, and we will define directly the vector coming from the model itself. The next improvement in PMI, we can have so-called reference dimensions. Reference dimensions are typically these characteristics or these values being in brackets here, and we do not create from these bracket dimension a characteristic now anymore, so that are normally only for datums and for references. The modifier CZ semantically should be read out for combined zones for whole as the PMI information into CALYPSO. So in the datum reference frame, say for instance here this positions 01 and then CZ, and then my datum reference AB. CZ is for common zone. This is for a bore pattern. Next to CZ, we can have an SZ. SZ is for separate zone. Separate zone is a discrete position value. And normally, these modifier should be implemented in the model itself here. But whatever, in any cases, it can be that there's no CZ or SZ defined. And the ISO is saying, if there's no CZ or SZ defined, use discrete positions. On the other hand, the ASME is saying, no, use a bore pattern. Okay, so the very best is if it's defined in the datum reference, and if it's not defined, we can now use our additional settings in the PMI dialogues, where you can define the preconditions for tolerances of position. You can define if there's no CZ or SZ, should it be a bore pattern or should it be a discrete position. The modifier CZ, okay, also should now create a so-called recorded center line here. This is the button, the icon for the recorded center line. This is valid for the specification, a whole group with position tolerances with CZ and no M in the tolerance indicator. No M for MMC. Okay. Recorded center line will be created then automatically. If we have an PMI information containing E for the envelope here, then the envelope symbol for size should also create automatically the measurement strategy for the envelope and the so-called pen element here. So this is then the 2-point, for instance, the 2-point distance diameter. A PMI, so going on another way, a model-based definition world in the CAD model, there we can have so-called views. Okay, so that are the views we see when we load the model in CALYPSO. This is the tab PMI. The view here, it's called section view 1, section view 2, and so on here. And now we have a function in Calypso. If you click with the right mouse button on the name of the view, then there's an additional dialog, create characteristic groups from all PMI from the view. And this is can be a very helpful, very powerful functionality, especially if the views in the model are they have a useful naming syntax. Okay, view on the top, view on the bottom, views on the left side or on the front side, and so on. Or maybe it can be also whatever significant characteristics here and different names. Okay. And if you are using the new functionality, you can create the same structure, the same group structure with the same group name like the view name in the PMI structure in the model itself. Okay, and this is then very easy. You can create the same structure like in the model directly in the Calypso characteristic tree view. Okay, and also remember in Calypso you can easily create a mini plan from an characteristic group, and then in combination it can be a very clever function to organize your measurement plan according to the views coming from the model. Calypso optics, we have improved the last years in every Calypso version. Also in 2020-22, we will have new functions. First of all, now Calypso will support the ZEISS detect. ZEISS detect is a hardware product family for optical CMMs here, and now you can use all the Calypso functions here, like autorun palette measurement here. You can use all our reporting functionality in Calypso, and also function like Calypso PCM, like curve, like freeform, like Calypso dynamic planning for dynamic inspection sequences are possible. And also the link to the PyWeb enterprise solution is also now technical included. And also as a note, the Calypso curve is included in the basic package for the ODetect. The optical light linearization we will have now with Calypso 2022 here, and this is a very big benefit because it significantly reduces the programming effort, especially if you have more than one CMM. So in the past, okay, we have to adjust the lights if you go to another CMM here, to other optical CMM with the same inspection plan. This is not necessary anymore, and so measurement plan can be easily transferred to other CMMs, and also you do not have to readjust the light setting when you change the zoom level, and also the slider for the sensitivity is increased, and also the light settings are increased here. These are the dialogs for the light settings. We have new defaults here, and we have an icon whether the linearization is on or off here. So that are the icons here. Here. This. And also remember the pre-request is the CMM has to be prepared for the light linearization. Okay, so this is also not only a direct function in Calypso software, so you have to adjust in the firmware and the hardware different settings. Okay, it will come first for new CMMs, and in later steps are also for CMMs which are on the market. Here there should be also a retrofit package available. Next improvement is the optimization of the image field correction to improve or increase the accuracy for the optical CMMs. So for the principle here, this is the result of the image field correction. So we will have better accuracy, especially on the core and in the edges, in the edge area here. And this has now a lot of advantages. So first, we can use and enlarge the field of view by using a smaller magnification. And if we can have more elements in one captured view, then compared to the past, then we can also measure faster. More productive functions in Calypso we will have. For instance, the start page is improved. So the start page itself, this is the, the new dialog for the start page. We have the function pin measurement, pin favorite, last, the recent used measurement plan. You can define your favorites by depending how many stars you wanna click on. You can pin it on and off. Here this is off and this is on. Here if you are using the mouse over function here, using the mouse over function, you will get a preview of your measurement plan. Remember, the preview of the measurement plan is the picture when you save your measurement plan. So remember, you have your Calypso measurement plan, and then you have whatever part, okay, and this part is inside of the CAD window. And if you press the save button, then this is the automatic preview window which will be created. So tip, before you press the save button, put your model, maybe fit your model and do it the way you want to have it, whatever rendered, and then press the save button, and then you have these very nice preview icons. This is a function this is a recommendation from my side you should use it here as default, and this is to improve the performance and stability. So when we measure in Calypso, we always have temporary data being written on the hard disk here. And these temporary data you can save as a file format, as a binary file, or like it was in the past, save actual points as a text file. Okay, that was default in the past. And especially if we have a lot of data, a lot of points, for instance, the freeform, or a lot of scanning points, then we have millions of readings and writings here. And this is much more stable if you are stable, and also much more faster if you are using the binary file format. To define it in extra setting, Miscellaneous system, and then define the file format here. We have the automatic subsequent evaluation for increasing the CMM performance here. So the idea behind the automatic subsequent evaluation is we have several CMMs, okay, and they are staying in, let me say, in the production surrounding. And the target is to measure as fast as technical possible parts, okay, and that means everything which is not 100% necessary to do it directly on the CMM, do it on an evaluation computer. And this is the principle and the idea behind. And the way we are doing is we have, this is my CMM computer, CMM1, can be more than one CMM, and we will measure only on the CMM, and everything which is, let me say, time consuming. So for instance, calculation or creating reports and things like this, we will do it on an evaluation computer. And the way we are doing is we are using these so-called ZMP files. Okay, they are containing all the information. So, and computer one, CMM1 only measures very fast, sending the results then to the evaluation computer. Okay, and the evaluation computer is always waiting, and if a value is coming, it's only calculating. Okay. And the system is so clever. We can you can hook on not only one CMM, you can hook on more than one CMM, okay, and then the evaluation computer is calculating values from CMM1, the inspection plan values from CMM2, okay. So, and okay, these are the prerequisites. Prerequisites is we need the same measurement plan and the same software options which is on the CMM computer, also on the evaluation computer. Okay, so if you have curve necessary on the CMM computer, then you need also curve option on the evaluation computer. So, and this is not this is an option, but it's free with free license. If you want to have the function, you have to activate the function. Activating the functions, you go in extra setting, miscellaneous license, and then you tick on the checkbox for automatic subsequent evaluation, which is a free license. Okay. Doing this, then you have on the evaluation computer you have to activate. You have new dialogues, subsequent evaluation. Okay, you have to define the paths here, the network path to the evaluation computer, and you can also say, do not calculate characteristics on the computer, on the CMM computer. Only, let me say, fetch the data for the element and the rest sent to the evaluation computer. On the evaluation computer, okay, okay, they are waiting then for the results, so-called ZMP files. So there are also PCM commands available to activate or deactivate. It's called auto subsec eval and then 0, 1, 2. 0 is normal mode. 1 is no report, but calculation of the feature. And 2, this is, let me say, the fastest mode. Only fetch values, no calculation of the feature. We have an improvement in the extension of the measurement direction. So this is especially if you have an bore. Okay, so this is a bore, and if you have a stylie and you have to go into the bore with the stylie, and if you have to measure a circle here, and then you will go out of that bore, and if this is not perpendicular. So in the past, you have to make some whatever intermediate points or so on. If you do not do this, then you very often can happen that you will make a collision here. And remember, Calypso is feature orientated. We can measure, it's independent. Every characteristic should be measured independent from each other. So, and therefore they're thinking of having intermediate points, normally also to which element does it belong. So we have now the setting called feature and a new setting called stylie. Okay, and stylie is for all the elements in the direction of the probe with, for instance, straight line, rotors measurements, and so on. And typically use case for stylie is if you have a point, a straight line, a plane without axis, okay, in a rotated hole. Okay, and the setting, the use case for feature is the default, since we have it since years, that are for elements with an axis like cylinder, cones, and so on, an outer element here, so on. So, and okay. So the tip, the length of the safety distance applies from the direction stylus after the retract distance, the king point, okay, corresponding to the element. Okay. Yeah. I made a small video to explain it more better here. You see, this is an hole, and now here you see in I have activated here my clearance position, and you see these are the default behavior, and normally I would expect I will make a collision here. We'll see. Activate simulation. Okay. And now you see this is my collision because the direct path is perpendicular from the clearance plane to the position of the element. So I know for doing this you have to make some whatever intermediate position and so on. And now let's have a look the new behavior. Direction is not feature, it's now the new behavior styly. Okay. And now you see I will change the clearance distance and see what's happened here. Okay, so if I'm modifying, you see this length is now changed. You see this is the king point here. Okay, the king point for that value here. Okay. And now see the changes. And now it works without an intermediate point. Okay, you see this is for the new setting, this is the king point. So this is the value here that in my case is the reject is the 20 millimeter or 20 millimeter, which has an influence. We will have now a very powerful function if we have measurement plans containing PCM. So in the past, the principle of PCM is we have a part, okay, and this part, let me say, has different variants. So it can be longer and whatever, different sizes. Okay, so this is typically a PCM task, making one inspection plan and handle all these different variants by changing, for instance, a value. Okay, say for instance, this is a, instead of hard-coded distance, this is a parameter. And this principle has been used very often. But on the other hand, we have a database, our reporting. Okay, and like in every database, a database has one nominal, okay, and a lot of actuals. Okay, and now if we have these PCM versions, so same inspection plan, same measurement plan, different versions. This is let me say, in the past they do not work together with a database. And now we made a very easy and simple solution. Okay, we are using and the first you have to activate the function, and if you activate the function, we will create for every variant a different database. For every variant a different database. And to activate this, you have to go into resources, result to file, PyWeb reporting, and activate the checkbox separate database for each variant. Okay. And then you only have to fill up the protocol header field variant with a value. Okay. And if we will find a value for a variant, we will create these independent databases. Okay. And then you very easily can separate the different variants and analyze the data. Here you see now there are errors on it, details, and now I was activating the details, and we show all the positions in the model. You can activate the plots without programming plots, so it's not necessary. Plots are always automatically available. Here you can go into details, and okay, then you can grab for more values. Yeah, if you want to have more than 10 values or all the statistic for, you need reporting plus. You see here, this is the error value, okay, correction value, measurement value. Here, 4 individual measurement values you can select. this is the selection list for what you want to have. This is we call it legend here, explanation what we will show. And always, if you click in one of those flags, we will open the trend protocol in addition, and then from the trend protocol you can jump into more details without programming. Everything is interactive. So there are 4 measurement. All this X, Y, Z are the measured position here, and for sure, if you want to have all these statistic values, okay, you need the PyWeb Reporting Plus license. Here are filters on it. You can remove those filters if you are interested in any individual value. Okay, so you only select the section which are interested, and for sure, remember my example with my 4,000 characteristics. 4,000 characteristics you can't bring on one page, so you have to make clever selection what is possible here, or search for it here. You can also separate very clever data here. Data separating, say for instance here from customer here. So then these data are separated automatically according to the customers. And you've seen I was only clicking into this chart here, and then clicking in this chart means I will open the trend protocol, and inside of the trend protocol you can also click the element which are interested, say for instance this one, okay, and then you can fetch more details automatically. So the last 2 functions I want to introduce with Calypso 2022 are hardware functions in combination with the activation in Calypso. This is the ZEISS acceleration mode called ZVR and ZVRA. It's for ZEISS vast rotary table and ZEISS vast rotary table axis. Okay, so it requires the hardware. Will come with a new Prisma Fortis at the end of this year. Okay, and we'll see in future we'll get also retrofit packages for this, and this is for special application, blade airfoil measurements, and also defining rotary table axis, and depending on the use case can be time saving up to 70% here. To activate the function in Calypso, first, as I mentioned before, okay, you need the hardware requirements, the hardware, the Prisma Fortis here, and this is also covered with an option. And then you have to activate the function, and activating the function is that button here in the rotary table dialog, ZEISS vast rotary table A for axis here, and then these are the second settings. Here, this is the speed and the acceleration for the ZEISS vast rotary table. Yeah. Next, we will have for every geometric element, if you measure with a rotary table, so-called measurement parameters, what you can set up, and using the Calypso curve, you have also now the function for tangential probing in the curve if you have this ZEISS acceleration mode available in future. So now let's have a look how the hardware will work, and if the settings are activated. You see this is establishing the rotary table axis. Okay, on the right, this is the new ZEISS acceleration mode. Okay, and this is the existing one. And you see here in this example, compared here, this example, 24 seconds compared with okay, more than 1 minute. Okay, and establishing the rotor table axis. This is a very task that you have to do very often if you measure with a rotary table. Yeah. So second task was measuring with the rotor table. Okay, measuring with the rotor table is also significant faster depending on your measurement on the part itself. Yeah, and this is a part here for blade airfoil, right? You see, in this case 8 seconds. On left, it's here takes much more time. Okay, so this is really also for me extremely impressive to see the performance boost here on this is firmware, hardware, and controller improvements, and establish the setting in Calypso how to activate. I have shown you before.